Hi everyone, we are asking today, how much weight do you lift when doing a push-up? And so if you want to remember, we're talking about weight and not mass. So weight is going to equal mass times gravity because it depends on gravity. So, you know, if we're on the moon, gravity's different, our weight's different, that whole thing. So, in this little diagram over here, we have like our person and they're doing their push-up with our average person. Their mass is 50 kilograms and their height is 1.8 meters. It's like an average girl. And so basically we have our angle theta here, kind of like the position. It's very similar to a right triangle when you're doing the push-up. So we have this little spot right here. This is our center of mass, and that is 0.9 meters kind of away from the start of them. And then the whole length, like up until their arms, is 1.5 meters because like it's not going to be 1.8 because you're taking into account like their head. We're talking about when the arms are out and you're like, this is all we care about. We don't care about this right here. So then we've got our little center of mass right here. So this matters. And so we're thinking the torque of the center of the mass equals the torque of like a normal reaction force. You know what I mean? So you're going down doing your push-up. The normal force is exerting back on you because that's how the world works. So we've got our weight. That's great. Times that length from the beginning of you to the center of your mass. Great. And then that's going to equal the reaction force on the person times 1.5, which is going to be that entire length that we originally had right here. So then we're going to make our weight mg. So we have mg times 0.9 equals that lovely reaction force times 1.5 meters. Excuse my handwriting. And then, you know, you do some algebra and you've got that reaction force to equal mg times 0.9 divided by 1.5. So this is our formula that we'll use. So this is kind of our little setup that we're doing to figure it out.
Alright, so from here we have our formula we're going to use, and now we have to plug in our numbers for the variables. So in this case we'll have mg, in this case it's 50 kilograms, times 9.8 as gravity, times 0.9, which is the center of mass, divided by the length of the arms, which is 1.5 meters. And then from here, you calculate all this together, and you'll get 294 newtons.
So then basically, the force, like that reactionary force on her body, is going to be 294 newtons from our math. But force also equals mass times gravity, as does weight. So the weight is the force. It's the same thing. So this is our answer. But if you want it in terms of like your weight on a scale or like in kilograms, you can just go ahead and take 294, divide that by 9.8, and you're getting 30 kilograms. So in terms of our original 50 kilogram like mass, you know, like how much she weighs on a scale, 30 kilograms is how much is being lifted. So that's a little bit greater than half of her body weight. Just to put it into conceptual terms. And that's it.